All right, in homework 12.1, we're getting ready for rational functions, and we're going to need two skills. You need some middle school fraction skills, and you need some factoring skills. I'll go over a few of these and make sure we know some tricks. On part B here, you can multiply it out and get 15 divided by 35, and then simplify it by dividing by 5 and dividing by 5. That works. But I want to make sure we all are familiar with a trick from middle school, which is that if you're multiplying by 5 and dividing by 5, that will cancel out. And so you can skip straight to the answer, which is 3/7. Similarly, notice in this one you are multiplying by 127 and dividing by 127. You could put this over 1 and then multiply straight across and then simplify, but those are going to be some big numbers. Much simpler to just notice that if you're multiplying and dividing, it cancels out. Okay. So for adding and subtracting, I think I'm only going to go over one of these. You need a common factor. You need or a common denominator, and usually we look for the least common multiple of all of these. So 2 and 5, the least common multiple of those is 10, but 3 doesn't go into 10. So the least common multiple between 3 and 10 is 30. So what we're looking for is we want to get all these denominators to 30. And so we use a special fraction trick of multiplying by 1 in a funny way. To get this one to 30, we multiply by 15 over 15. The reason this works is it's just multiplying by 1, so it doesn't actually change the value of the fraction. So 15 times 5 is 75, 15 times 2 is 30, and we got that denominator to 30. Here, to get to 30, we need to multiply by 6 over 6. So we multiply by 6 over 6. That doesn't change the value of the fraction because we're just multiplying by 1, so it'll be plus 18 over 30. And the last one, to get this to be a denominator of 30, we need to multiply by 10 over 10. And so we get plus 10 over 30. Once you have a common denominator, you just leave the denominator the same and add or subtract the numerators. So 75 plus 18 is 93, 93 plus 10 is 103, and this can't be simplified because the prime factorization of this is 2 times 3 times 5, and 5 doesn't go into 103, 3 doesn't go into 103, and 2 doesn't go into 103. So that is our answer. All right. When you are multiplying, you can multiply straight across. That's how you multiply. And I want to show two different ways of doing this one before I move on. We could do 3 times 5 is 15, 15 times 2 is 30, 2 times 3 is 6, 6 times 7 is 42. And then we could simplify by dividing each of these by 6. So you get 5/7. But, again, there's a shortcut for middle school we should know, which is notice here, 5, since you multiply across, and these are all being divided, see how 5 is being divided by 3 and multiplied by 3? That cancels out. See how 5 is being multiplied by 2 and eventually will be divided by 2? That cancels out. And so you can skip straight to the answer, which is 5/7. I'm not going to do this whole problem for you, but I do want to make sure our middle school skills are solid. If you have a fraction divided by a fraction, that's the same as the first thing. The way you divide by a fraction is you multiply by the reciprocal. And then you can just multiply straight across. Okay. When you are doing algebra skills, you just apply your fraction skills. So we are multiplying by 7x and dividing by 7x. Cancels, right? Here, you need to get a common denominator because you're adding two fractions. So the least common multiple between x and y is x times y. So here we multiply by x over x. Here we multiply by y over y. Again, we're just multiplying by 1. And so we can get 2y divided by xy plus 3x divided by xy. And now that they have a common denominator, you can add them together. I think that's all the ones I'm going over of those. You should know all your Algebra 1 factorings. I'll make sure you know factoring by grouping here. Again, when the a squared term doesn't have a 1 in front of it, the first thing you should look for is a common factor, but 5 doesn't go into either of these other ones. So we're going to do factoring by grouping. So the way that works is we multiply the first and the last one together, 60. We need to find two numbers that multiply to make 60 that add up to be 16, and that's 10 and 6. And what that tells you is how to split up this 16a. 16a becomes 10a plus 6a, that's that 10 and the 6 there, plus 12. and then you factor out the common factor from each of these groups. So 5a is the greatest common factor, times a plus 2, plus 6 times a plus 2, and now we have a common factor of a plus 2. And so we factor that out of both of these, and what's left over is 5a plus 6. So 5a plus 6 times a plus 2. These are advanced factoring techniques. I will not do them for you, but I will tell you, you should recognize this is a quadratic, where this is something squared. This is that something. Here's e to the x, and here's e to the x squared. E to the x squared, the property of exponents says that when you do a power to a power, that's e to the 2x. So this is a squared plus 3a minus 4, and you factor it just like a quadratic. Here, this is a sum of two cubes. This is x cubed plus 10 cubed. You know your sum of two cubes. Here, this is a difference of two squares. This is a to the 4th squared minus 1 squared. So you can use your difference of two squares things from Algebra 1. And what we should notice here is this is 1 over x cubed. The power of 1 over x goes down each time. Here's 1 over x squared. Here's 1 over x. There's no 1 over x's. And over here, this is minus 2 cubed. And this is one of our formulas that we should be able to recognize, where it's, you've got a cubed minus 3a squared b plus 3ab squared plus b cubed, minus b cubed. And when we have something like this, this is a minus b cubed. That's our cube binomial trick, and that's what's going on here. All right, there's also answers at the bottom to make sure you're getting them right. If you just try to write down the answers or like bullshit your way to writing down the right answer, that would be very bad. Make sure you understand how to do each one of these. On the back, I'll do a couple of these with you. You're plotting f of x, you're graphing f of x by evaluating f of x at each x value, and then plotting the points. So when x is negative 10, f of x is 1 over negative 10. So you can either write negative 1/10 or negative 0.1. Either way, it's fine. I'll do a couple of these points. When x is negative 1, you get 1 over negative 1. 1 divided by negative 1 is negative 1. When x is negative 0.5, you get 1 over negative 0.5. And this is the same as 1 over negative 1/2. The way you divide by a fraction is you multiply by the reciprocal, which is negative 2. 1 over 2 turns to 2 over 1, which is 2. So that's negative 2. I'll do one more. 1 over 0.25 is the same as 1 over 1/4. And the way you divide by 1/4 is you multiply by 4 over 1, which is 4. Another way to think about it is that you're saying how many times does 0.25 go into 1? 0.25 goes into 1 4 times, right? 0.25 plus 0.25 plus 0.25 plus 0.25 is 1. So 0.25 goes into 1 4 times. The way your graph should end up looking is something very similar to this. Oh, that's wrong. Oh, dang. That is terrible. Woo. I'll do it in red instead so you can see it. Should look something like this. Boy, that was terrible. That blue graph up here is not correct. None of this was right here. And on this side, it should look like this. Something like this. Just to make sure your graph's right. Make sure you plot your points very well. All those points should be able to be done there. And then you should be able to answer these questions. The domain, the only one I'll help you with is the domain and the range. The domain is all the possible x values, and we write this a little bit funny. Notice that the x values keep going left forever, and then they keep going, they get closer and closer to 0, but there is no x value at 0 because you're not allowed to divide by 0. So the domain values are from negative infinity to 0, but then they start up again. There are other x values from 0 to infinity. So the domain values, they're x values that keep going to the left and keep going to the right, but there is no value at 0. There's a couple ways to write this. I'll write it a few different ways. Using interval notation, we write the domain is all the x values between negative infinity and 0, with parentheses because there is no x value at 0, and then it starts up again at 0 and goes to infinity. Again, there's no value at 0. We put a union in between. It's this little U symbol, and it means all of these and also all of these. Basically, this is all real numbers. There's another way to write this, which is this is all real numbers except for, we use a backslash, except for 0. You could also write it out in words. All numbers except 0. You could even write it using set notation by saying x is the set of x's that are less than 0 or x's that are greater than 0. But it can't be 0. So x can be less than 0, x can be bigger than 0, but x can't be 0. All right. And I'll let you do the rest on your own. Good luck in the rest of your homework.